Greetings of the day. I am Sowmyadevi. I am going to give you a very brief discussion on the topic of deadlocks in operating management system. First of all, we should know what do you mean by deadlock, why it is occurring, for what purpose, and then for what purpose it is occurring, and then how we can able to manage it, or we are going to prevent it, or we are going to manage it, or we are going to avoid it totally. That is, we are going to see today's topic. First, our operating system is a multi-programming environment system. Here, number of processes will execute at a time. That means there will be finite number of, but for execution of any process, we have finite number of resources. If any resources are not at all available for any process to execute, means the process will wait for some time. And after some time, if the process is there, if the process is released by some other process, then the process will start to execute. But if the process which is waiting for again and again, which cannot able to change its state from waiting state to running state, then the requested process has been held by some other process or some other waiting process also, which is also waiting for some other resources. So as the process is waiting for so long time, it can't able to proceed to execute, then the situation arises is called as a deadlock. That means there is no execution at all by any process or by that process or by only one process. Then the situation arises called as a deadlock. How we can able to detect it? How we can able to prevent it? We are going to see them in upcoming slides. Any system that is in our distributed operating system, that is we have number of resources. For all the resources, we need identical instances. That means for the number of resources, if there is two resources, it should have multiple copies. Then only if any two processes are going to request for that resource by two process for the two instance of resources, then only both the process will acquire that resource. If this kind of task is occurring in our system, then we can able to avoid the deadlock. That means the number of requested resources should be available at any time. Or if the resources are requested by the process, it should not exceed the available number of resources. Consider the resource R1. It has instance of 3 instances, but 5 processes are requesting for that resource. We have only 3 instances, but 5 processes are requesting, means then at that time the process has to wait, or it has to, or it the resources has been acquired by the some process is not at all releasing, means then deadlock will arise. So it should not exceed the total number of resources available. The process which is utilizing the resources it utilize the resources should be executing in the following sequences. That means it first request for the resources. If the request is not guaranteed immediately, then the requesting process must wait till the resources is acquired. Then it has to use it. Then after using the resources, then it has to release it immediately. Then only the other waiting process will change its state. That means it will acquire the resource and change its state, and it will start to execute. If these three processes are not doing very properly, that means requesting is done and using is also done, but it is not at all releasing, means that time deadlock is occurred. So we have to release the resources once when it is used. What are all the necessary conditions or of government conditions that if these conditions are there, then we can sure that deadlock will occur sure. What are the conditions? First one, mutual exclusion. You know that when one process is holding the resource, that means only one process can hold a resource at a time. And if any other process are requesting for the resource, then the requesting process must be delayed until the resource has been released. That means what is the meaning means here if we are having any resources, that resource should be held by the process only one process at a time. No two process should hold the resource. If it is a readable resource means no problem, but if it is not readable resource means only one process has to hold it resource. If these conditions are there, then we might have sure that deadlock will occur. Then hold and wait. You know that if it is holding if the resource is holding by some other process, and some other process are requesting for that holded resources. Then it is waiting for so long, then the situation also arise for deadlock. Next, non-preemption. This is the third condition that deadlock may arise. That is, non-preemption means when any resources cannot be preempted, it is used by only that process means then the deadlock will occur. Then circular wait. Circular wait means that means if consider P0, P1, P2, P3, P4 or these five processes are there, and each and every process are waiting for P0 is waiting for P1 to release some resource, and P1 is waiting for P2 to wait to release some resource, and P3 is waiting for P4, and P4 is waiting for P5, and P5 is waiting for P0 for some kind of resources. That means all are waiting for some resource, not at all executing. So in that time case, that means all are waiting for some kind of resources only, but not at all executing. So circular wait. This means circular wait. Not at all process are executing means then this kind of situation also arise for the deadlock. So what are the necessary conditions? If that is mutual exclusion, that hold and wait, no preemption and circular wait. These kind of situations are there means then we can sure that deadlock has been occurred. Deadlock will occur in our system. So this deadlock we can able to detect with the help of resource allocation graph. It is a directed graph. It has number of resources. In this graph we have to represent the resources and then vertices. That means vertices are nothing but your what are the nodes, what are the process we are going to use here. See, we will see. I will explain you with the help of a small diagram that consider this process is that means a process P1, P2 and P3 are there. And R1, R2, R3, R4 are there. That means here R1 has one instance and R3 has one instance and R2 has two instances and R4 has three instances. Here P1 is requesting for R1 and P2 is requesting for R3. That means P1 is requesting for R1, but it has been assigned to P2, and then P2 is requesting for R3, but it has been assigned to P3, and then R2 is assigned to P1 and P2, but R4 has three instances. It is not at all requested by any process, and it is not at all assigned to any process. That means from R 2 to R P1, that means a directed arrow mark is there. That means R2 is assigned to P1. And again, arrow mark is from R2 to P2. That means the resource R2 is assigned to P2. An arrow mark is there from P1 to R1. That means P1 is requesting for R1, but it is assigned to what? P2. And again, P2 is assigned to P2 is requesting for R3, but R3 is assigned to P3. So when P1 will execute, it has one resource R2, but it requesting for R1. When these two resources are available, then we can say that P1 will execute. Same thing for P2, it has R1 and R2, but it is also requesting for R3. But R3 has been assigned to P3. When R3 is available, then P2 will execute. So we are waiting for P3. P3 is needed only one resource, that is R3. After the completion of P3, after the completion of P3, the R3 resource will be released. So automatically P2 will execute, and after executing of P2, if it release its resources, then P1 will execute. So this your how the process are requesting and how the resources are assigned that can be understood with the help of this resource allocation graph. That means the edge from R2 to P1 means that is assignment edge. P1 to R1, that is called as request edge. It is requesting for R1, so it is called as request edge. Then how we can able to deal this deadlock problem? The first way, that is we have to prevent the deadlock. Second way, you have to deduct it, recover it, and third one is you should assure that deadlock will not occur at any time in our system. That is these three ways you can able to deal with your deadlock. To ensure that deadlock will never occur in a system means either you have to use deadlock avoidance or deadlock prevention. In deadlock prevention, we should have at least any one of the conditions should not occur. We have seen that mutual exclusion, non-preemption, circular wait, and hold and wait. These four conditions should not occur at any time. Then we can able to prevent our deadlock. Deadlock avoidance means we allow it for occurring for any deadlock, but we can able to prevent it. And last one is that deadlock detection or prevention should not occur at any time. If it occurs, means then the performance of our system will be that means reduced. First thing we are going for today, we are going for deadlock prevention. That is, two ways are there: deadlock prevention and deadlock avoidance. But I am going to explain you first deadlock prevention alone. For deadlock prevention, I said that means all the four conditions should not occur at any time. First condition is what? Mutual exclusion. Mutual exclusion will occur only when that means when one process is holding one resource, it should not be used by some other process. So that is mutual exclusion. That is we are maintaining this condition for avoiding some unnecessary problematic conditions. But if this has been there, then we can say that deadlock will occur. So how we can able to avoid it? Then we should have only non-share. That means shareable resources should be there. Number of shareable resources should be there. Shareable means number of process can able to share the particular resource. So no problem will arise. Then all the process can able to access the resource. They can execute. They can give our output. So mutual exclusion can be avoided when we are having number of shareable resources. Next one, hold and wait. This condition can be eliminated by forcing a process to release all its resources that is held by it when it is requested by some other process, that is, or when it is not at all available. That is, hold and wait means if a process is holding some resources but it is waiting for some other resources but it doesn't get that resource, means it is going on waiting state. But we have to mention that time, that is wait bound time. That means consider when P1 is holding some resource R1 but is waiting for R2 for some time. That means there should be a time limit for particular time that P1 has to wait for R2. Until that time, if P1 doesn't get that resource R2, then it has to release its resources. That means it has to release the resource R1. So then, because if any other process are waiting for R1, then R1 can be get by that process. So hold and wait should be eliminated by releasing its resources when it is requesting for some other resource which is not at all available. Non-preemption. To ensure this condition never occur, the resources must be preempted. Preempted means if any resources are requested by some other process, but it is held by some other processes, means we have to forcibly make to preempt it. That means it has to release it the resource. That is forcefully we are doing to release the resource. If we are doing this, then non-preemption will not. That means a deadlock condition will not occur. We have to preempt it, not for no preemption. That means we have to release the resource. That is the only one solution for avoiding the deadlock. Next one, circular wait. In circular wait, I have said that all the processes are in circularly waiting for some other conditions. In last example, we have seen P1 is waiting for P2 to release the resource and P2 is waiting for P3 is releasing the resource. If P3 has completed, then P2 will execute. If P2 has executed, P1 will execute. So this is a circular wait. So when P3 is not at all executing, means it has to release the resource. That means we should not maintain the circularly they are waiting for particular kind of resource. If P3 is waiting for some kind of resource, means if it's not at all getting, then it has to release the resource. Then automatically P2 will execute, then automatically P1 will execute. This is our deadlock prevention method. That means all the four conditions: mutual exclusion, hold and wait, non-preemption, and circular wait. If all these conditions are we are eliminated, then we can able to prevent our system from occurrence of deadlock. That means mutual exclusion means the none of the process should hold its resource. If we have to release the resources. Hold and wait means if any process is holding some resource but it is waiting for some other resources also. For particular time it has to wait. If the time bound is exceeded, then the process has to release the resource. Then non-preemption means we should not allow the process to hold it for some time. That means we have to make the process to forcefully release the resource. because it is requested by some other process. Like circular wait means we have to eliminate the circularly waiting for some kind of resource. That means if one process is executed, then only all other process will execute. We have to avoid this condition by avoiding the we have to avoid this condition by releasing the resource. So main concept is that if any process is waiting for some resource, that process has to release all the resources, then only it has to request the resource. So if these conditions are avoided, then deadlock will not occur in our system. We are preventing the system from occurrence of deadlock. This is the first method we have seen today, that is deadlock prevention. In upcoming class, we will see that deadlock avoidance, the very important concept, that is Banker's algorithm. Thank you.